proportion of persons with Alzheimer's at different degree of severity is at least 10% of the elderly population. So it's a huge social problem. Starting from around 40, 50 years of age, a toxic protein, which is called A-beta 42, starts accumulating in the brain and intoxicates the neurons. Once the neuronal loss has reached a certain threshold, clinical symptoms start to appear. Over time, however, the neuronal death goes on and the person develops disability, difficulty in doing usual activities of daily living. This is the stage where the patients have what is traditionally called as Alzheimer's dementia, that the disease starts really decades before disability.
Dr. Giovanni Frassoni leads a European research project called neuGRID. neuGRID is a new, user-friendly, grid-based research e-infrastructure enabling the European neuroscience community to carry out the research required for the pressing study of Alzheimer's disease and other degenerative brain diseases. The success of neuGRID could result in two significant outcomes: earlier detection of memory loss and better drug development.
The expertise and the computational resources to perform these types of analysis are currently very much localized in a very small number of brain imaging centers around the world. But there are a lot more people who would like to be able to do it. They just don't have the expertise, they don't have the algorithms, they don't have the data. So the idea behind neuGRID is to make all of that available very easily to anybody who wants to get access to it.
neuGRID will contribute to the development of the European research area by making available large amounts of imaging data paired with computationally intensive data analysis and computational resources to small laboratories without imaging facilities. The neuGRID project builds on existing research in neuroimaging-based grid infrastructures. Processing brain scans, such as those from the CIVET cortical thickness analysis pipeline or workflow, can commonly take up to 8 hours for a single scan. neuGRID aims to enable neuroimaging researchers to quickly extract knowledge from thousands of brain scans by increasing the data efficiency of these workflows.
You need something that can very quickly, in few patients, can give you the answer, is this drug working? So I can go on investing tens of millions of euros or not, without waiting to check whether the patient is going to become demented or bedridden.
If we could do those massive analyses at the push of a button across incredibly large populations, that would increase our ability to perform this type of research tremendously. You could build massive compute centers in one location, but for one, they're very expensive to set up. The grid is essentially an alternative where you have cheaper, smaller local installations, and then you network them all together into a much larger whole.
To follow Alzheimer's patients over time to see how their disease progresses or how they respond to treatment, you need a fairly large number of scans. So the advantage of neuGRID would be that you can do the computation using neuGRID as a toolkit that is available on the internet.
The neuGRID project is pan-European. Team members come from Italy, Spain, the Netherlands, France, the United Kingdom and Sweden. Before the project was even approved, Professor Richard McClatchy and other technologists visited the 3 proposed partner medical institutes to ascertain the needs of the brain imaging user community. The institutes are FBF in Brescia, the VU University Medical Center in Amsterdam, and Karolinska Institute in Stockholm.
The purpose of those visits was to understand the processes and the workflows that they undertake so that we can start to represent those workflows in computer format and that we can provide them with the services they need to support those studies. Another important aspect of working closely with them is to cement the kind of understanding between the technical community and the clinical community.
We have users which are of, I would say, rather basic capabilities. I mean, they're the typical clinical researcher who don't know very much about computers, but they have a data set and they want to be able to run some analysis on it efficiently. neuGRID, they were really interested in trying to understand what it is we do and also in creating a common language.
One of the things that we determined through a requirement study was the need for clinicians to be able to debug the pipeline in the first place and ultimately to run those pipelines on a vast number of brains. To do that, we have created something called the pipeline service. This pipeline service enables users to specify the elements in the pipeline and save that in our database. Secondly, we've provided something called the provenance service, because in running those pipelines, what we need to do is to capture the history of the data to provide traceability from the outset through to the decision and outcome.
The feeling I have is that if you put your data into neuGRID, you can be certain that you have put your data into an environment which will keep your data and the processes you apply to it integrally safe. Not just what happened to the data, the provenance, but also the ethical boundaries that have been put on the data. So you have sort of a friendly hand in the small of your back that will help you keep you steady on your feet.
This is something that is a collaborative effort. So you have to be able to interface with other modules that you want to use within neuGRID, or you have to be able to interface with other infrastructures and etc. So there is a variety of challenges with that, but I think that's essential to the success.
With some effort, it might be possible to build a global computational infrastructure, something like the internet. The internet servers can be accessed from all over the world, and you do not know to what server you are connected at any point in time. You only know that it works. This is what we want to develop.
Within the neuGRID project, we are using visualization tools that most of the time are only available on specific operating systems. And most of the time it's under Linux or Unix or something like this. And of course, most of the end users are using a Windows operating system. So once logging into the web portal, you can launch the different applications as if they were running on your own desktop, but they are in fact running remotely.
The neuGRID project is about not simply having a set of computers, but encapsulating it with some software that make it easier for people to use the grid, because simply having a grid is not enough for simple doctors like me.
Research projects in the USA, Japan, Australia and Europe have already captured over 10,000 brain scan images from patients with early memory loss. neuGRID aims to deploy a service-orientated architecture to mediate between user applications, the back-end system and other systems through the grid. This service-orientated approach will allow neuroscientists to identify neurodegenerative disease markers through the analysis of the ever-growing dataset of 3D magnetic resonance brain images.
What we have done so far, before we had those big data sets available, has been something like trying to reconstruct the plot of a film by watching very short snapshots. So neuGRID was an answer to the availability of an enormous amount of data that is hiding secrets to unravel which you must have suitable computational tools. In the near future, we might have 20, 30, 40,000 images, and neuGRID is a starting point. neuGRID will need to enlarge together with the growth of the data it will analyze. We are now at the second year of neuGRID, and the infrastructure is working. So grid computing really works.
neuGRID is a European-funded project as part of the Framework 7 programme. The infrastructure is designed to be expandable to services for other medical applications and is compliant with EU and international standards. neuGRID is making a significant contribution to the research into brain disease, a world problem.
We feel very responsible for the use of this public money and the impact that can have in health, in citizens and so on. But from what we see and from what they write in the reports, we see that they are achieving good results, and this public money, at least for this project, is spent the right way.
It's very enriching from a personal standpoint to be involved in such a project, which has genuine medical objectives and enables me to bring whatever expertise I have to help them resolve real-world problems.
To see that now this whole movement and this whole effort to make this kind of stuff available, these kind of analyses available to the world at large is very, very rewarding to me personally and professionally.
If you know people with Alzheimer's, you realize that it's really something that you would never like to experience. They find themselves in a present without coordinates of the past. If you don't have the coordinates of your past, you can't plan the future. You can perceive a deep anguish. And thinking of the idea of addressing and try and give an answer to such a humane problem is something that can give meaning to a profession.